So our first step is to get the one side equal to 0, yes? And then we are going to factor. So we first have to pull out an x. Always look for that greatest common factor first. And then you have a nice, easy quadratic factoring. Guys, you have got to get comfortable with factoring. I'm in the middle. I got the first part of your test graded, not the second day. Some of you guys, it's like I would rather pull fingernails out than factor. Just factor. Okay? So, you're going to take each one of these and set it equal to 0. So if x is set equal to 0, it's 0. X minus 6 set equal to 0 gives me 6. And then x plus 2 gives me -2. So those are our x-intercepts, yes? So we're going to kind of draw a little x-axis, if you will, here. You're going to place those on it. And now we are going to test points. Okay? So let's put -3 in. -3 out front. -3 minus 6 is -9. -3 plus 2 is -1. I have 3 negatives multiplying, so that is a negative region. And let's try -1. -1 outside is still -1. -1 minus 5 is -5. I'm sorry, -7. -1 plus 2 is a +1. So that gives me a positive region. Does everyone understand where I'm getting these positives and negatives? Yes? Ask questions if you don't. I'm going to put in 4. 4 out front's a positive. 4 minus 6 is a negative. 4 plus 2 is a positive. 1 negative makes a negative. In our last, let's put in a 7. We're going to get positives all around. So you need to make sure on your quiz or test or whatever when it asks you to do this, you do not just start and say, well, I know the first one's negative. I can just boom, 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 because I want to see the numbers that you're putting in. I should see pretty much what I did. Okay? So the question is asking, when is the function greater than 0? So that means when is it positive? So it is positive between -2 and 0. It goes positive again after 6, so 6 to infinity. We are not going to use square brackets because it does not say greater than or equal to 0. Only when you see that or equal to would you use square brackets. Okay? Again, what this tells us is we have a function that is negative, comes back down, hits 0, comes back down or up and hits 6. So you can kind of get a general sketch of how this thing is above and below the x-axis. Okay? That's kind of where we're going to with this. When is it above or below the x-axis? All right? Okay, so today we're actually going to start Chapter 3. And Chapter 3 deals with polynomial functions. And you know a lot of what we're going to do, and a lot of it's going to be review, but there's going to be some things that you don't know. So we are going to deal today with just quadratics, which we know, right? Everything we do today, you did last year, guaranteed. Whether you remember it or not is the question. So we're going to go through it just like you've never seen it before. So ask your questions. Make sure you tell me to pause if I'm going too quick. So this is considered, and I have to watch myself because I called this something different. This, we're going to say, is the general form of a quadratic. ax squared plus bx plus c. Okay? So if I'm looking at that form, somebody tell me something you might know. C is the y-intercept. That's one thing you can get from general form. One other thing, what can you get? Just looking at it. Just looking at it. We can tell the y-intercept is C. What else can you tell? It's going to be a parabola, right? And in particular, you can tell if it's going up or if it's opening down by looking at the A value, right? If A is positive, we have a problem with it's opening up. If A is negative, you have a problem with it's opening down. So those are things we already know about this form. There's nothing else you can tell. Okay? When you have it, what they call standard form, which we've always called it vertex form, but in this book it's called standard form. In this form, you can tell the vertex. The vertex is HK. So it's always opposite when you put it in the parentheses. You are subtracting it in there. The A value in this form is the exact same A value as it is in general form. So that A, again, is going to tell you whether it's opening up or whether it's opening down. You cannot tell the y-intercept just by looking at this form. You would have to plug a 0 in for x and then find it. Okay? So both forms are helpful for different things. So y equals a times x minus h squared plus k is your standard form. Okay. So let's write the equation in standard form of a quadratic whose vertex is 1, -5, and what passes through the point 3, 7. Okay, so the first thing I'm going to do is I'm just going to write my vertex into that that standard form. So we're going to say y equals a times x minus the h, and then the k is just going to get put outside. So that's how I'm going to start every time. I'm going to put my vertex in. Now that's pretty much the whole answer, except we do not know what the a value is. So what we're going to do is we're going to take this x and y that they gave us, this extra point that they're giving us, and we're going to put it in for x and y, just so that we can solve for a. Does that make sense? You can always put an extra point in, just like you do with writing a line. You know, you put the slope in and you put an x and a y in. What is 3 minus 1 squared? 4. So write that as 4a. Okay? The reason why I'm telling you to do that is a lot of times if you were to write that as a4, what do we have a tendency of doing in that point? 4 minus 5. We don't want to subtract 4 minus 5. This 4 is attached to that a, so put it in the front so we don't make that mistake. Okay? That's a real common mistake. All right. So to get a by itself, we are going to add 5, and then we would divide by the 4. And as soon as you have a, you go back up and cross out my a or erase it or whatever and put a 3. Does that make sense? Not real hard? Okay, we're going to try one all by our noses. Oh, you and your buddy, and then we'll go over it. So you're not really long. Try that one. You can do it. Okay. There you go. Is that what you got? Everyone's okay with that? All right, moving on. We are going to complete the square. Do you remember that word, phrase from last year, completing the square? Yes, it was so much fun. We did it over the summer, I'm sure. Here we go. So the first step is to get the c value, that constant, to the other side. You might want to write these steps down. I'm going to kind of say them as I go over this. So I'm just putting the c value on the other side. That's my first step. The second step, if you have an a other than 1, if you have an a value other than 1, you're going to factor it out now. But we don't. Okay, but if there was an a value, you would have to factor it. So now we are going to add something to make it a perfect square trinomial. So you take this middle number out, this b value you have, split it in half, and square it. So negative 2 divided by 2 is negative 1. Squared is a positive 1. That's what we're adding. You're always adding a positive. No matter what you have, you're going to square it, right? It's going to be positive. Room with me? Can you ever add something to just one side? No, you have to add it to the other side also. Keep things balanced. Now, the left side is just y minus 1. This right side, we want to factor it. Now, we have made it so that when I factor this, it is a perfect square. It's going to be the same factor, x minus 1, x minus 1. So we don't want to write it that way, though, do we? Think of the form we want to get it in. How can I write x minus 1 times x minus 1? You put a little square there. So you're going to write it in binomial square form. Okay, it's going to be a perfect square. So to get the inside, you can take the x and do the middle number. That half of the middle number is going to be sitting there. Okay, and then our last step is just to add 1. Take this one and put it over here. And now you have it in vertex form. Or standard form, as they call it. Okay? So what do we know about this parabola? What is the vertex? Positive 1, comma 1. Remember the x is opposite in there. What is, how's it opening, up or down? Up. So if it's opening up, what does it have, a max or a min? So all these things you can kind of answer just by thinking about it. What is the y-intercept? Huh? Is it 1? 2. 2. Got to go back up to the original form to figure out the y-intercept. Or plug a 0 in. Okay. All right. Do you want a little bit step harder? Okay. So first step, we're going to move the C value over. Now in this one we have an A value that's not a 1. So we have to factor it out. So I'm going to factor the 2 out. Guys, you have to factor it out even if it doesn't go into that middle term. You might have decimals. It's possible. And then put a plus blank. So we factor that A value out and then put plus blank. So take your B value, divide it by 2, and square it. What would I add to that parenthesis? 4. See that? Half of negative 4 is negative 2, squared is 4. What am I going to add to the left? So we added 4 in the parentheses. What is the parentheses getting multiplied by? 2. So on this side, to keep it really balanced, you have to add the 8. You got to multiply that 2 back through. So that's a little thing people forget to do. Okay? So left side, I'm at y minus 1. Right side is 2 times. When I factor that, it's going to be x and minus 2. Remember that middle number, split it in half. That's going to be your factor there. Thank you. Okay, and last step, get the y by itself by just moving the 1 over. Okay. Just want to try the second one there. See what you can do. When you factor out this minus 3, it changes that middle term to a negative 6. Just got to be careful when you divide them by the negative. Okay. Bless you. All right. So we already talked about these two. We're going to go from general form and finding the vertex without completing the square. Okay, so there's times when we don't have to do all that work. Okay, so the h part of your vertex is opposite of b divided by 2a. Remember hearing that last year? Should have. Who can tell me the quadratic formula? X equals opposite of b plus or minus square root of
squared minus 4ac.
Right? That's the quadratic formula. This is simply part of the quadratic formula. The vertex is that middle between the two x-intercepts. And you go to the left so much and you go to the right so much. You have those x-intercepts. Okay? So this minus b over 2a is part of the quadratic formula. That's how you find your x. And then, of course, your y, you always just plug in whatever you just did. Okay? You have an axis of symmetry with every quadratic. You have a line that it folds on. And that's always at the h part of your vertex. So it's always going to be x equals h. And we already talked about if a was positive, it would open up. If it's negative, it opens down. All right, so we're going to kind of put everything together here. Be able to tell all sorts of stuff. It's going to be so exciting. All right. So, first, let's tell me, does it open up or down? Down. Does it have a max or a min? Right? And what else can we tell just looking at it right here? Y-intercept is 7. Okay. Now, let's find the vertex. So the x part of the vertex, the h, is opposite of b over 2a. So that's negative 12 over negative 8. That's 1.5. So that's the x part of my vertex. To find the k, or the y part, we're just going to plug 1.5 back into the equation. And that is, what do you think? 6.5? Anybody putting this in their calculator along with me? I think it's 16. Try to remember from earlier. Am I right? Is it 16? Okay. So we have our vertex. It's 1.5, 16. Our axis of symmetry is just going to be x equals whatever the x in the vertex equals. You need to write that as a line. There should be an equation, x equals. Okay? So I could graph this easy enough. Let's write it in vertex form or standard form. Y equals x minus 1.5 squared plus k. What's the a value here? What's the a value? What was the a value? Negative 4. So this a value, that a value is the same. X minus h plus k. So you can write it in vertex form quickly that way too. Right? Keep in mind on a quiz or a test when it says use completing the square, you better use completing the square. But there's another way of writing it in vertex form or standard form. Okay? We can do that. All right. You're going to have to be able to do all of that and more. You guys don't have to write these down if you don't want to. Basically, you're going to graph, you're going to find all that information in addition to x-intercepts, which we'll talk about, and graph everything you know about it. Okay? So, what do we know? Just looking at it. opens up, has a min, y-intercept of -6. Perfect. Okay. So y-intercept 1, 2, 3, 4, 5, 6. We know it opens up. All right. Let's find the vertex. So the x part of the vertex is opposite of h times 2 times, opposite of b times, divided by 2 times a. So we have 1/2. And we're going to plug that 1/2 in. I already know this is opening up. So doesn't the vertex... Yeah, we can't tell that. All right. -6.75 is what you get when you plug that in. So our vertex is 0.5, comma, -6.75. So it's somewhere around here. What is the axis of symmetry? X equals 1/2. Right? So I can draw my axis of symmetry. Okay. Remember, your axis of symmetry is a mirror, yes? So everything on one side gets reflected on the other side. So I have my y-intercept here. I can go to the other side, same distance, and find another point. Yes? Okay. Let's find the x-intercepts. So x-intercepts, we're going to set the y equal to 0. And we are going to factor, or at least try to factor. When you think of factors that multiply to 2 but subtract to a 1, 2 and 1. So my x-intercepts are 2 and -1. You set the factors that have an x with it, equal to 0. Good? Remember doing all this last year? Vaguely? All right. Let's try another one. No, I think we got 3 slides left. We're doing well. Okay, this is already in vertex or standard form. So what can I tell just by looking at it? -1, 3 is the vertex. Good. What else? It opens down. Good. So it has a max. Okay. The y-intercept. Remember, to find the y-intercept, you're going to plug in a 0 for the x. So when it's in this form, you have to do that. When it's in general form, you can just say it's the c value. We don't have the c value here. -2 plus 3 is 1. So the y-intercept is a 1. The vertex is -1, 3. My axis of symmetry. And I can do my reflection point, as that's wide enough that you could sketch a graph without the x-intercepts. You're still going to find the x-intercepts, but you can see that we can do that. X-intercepts are when the y equals 0. We want to get x by itself. What's my first step? What do you get rid of first? The -2, the 1, or the 3? The 3, so we're going to subtract 3 to this side. What goes next? The -2 or the 1? -2. Now what do you got to do? Square root. Remember, when you take the square root, how many answers should we get? 2. So we've got plus or minus the square root of 1.5 equals x plus 1. Get x by itself. The last thing is going to be to subtract 1. So you get 2 answers. You get the square root of 1.5 minus 1, and you get the negative square root of 1.5 minus 1. And I want to say, if I'm remembering correctly, it's 0.22 and negative 1.22. This cannot be factored. You know, this is not a perfect square, so they're going to come out as decimals. Okay. And if you look on the graph, that seems to be right. So you've got to be able to do all that. Find the vertex, find the x-intercepts, the y-intercepts, the axis of symmetry. Whether it opens up, down, min, max. You understand when we say vertex, that is the minimum or the maximum point, right? All right. So no matter which form they give it to you in, you've got to be able to do all that stuff. Find all of it. All right. You have 100 yards of fencing to enclose a perimeter of a rectangular field. What's the maximum area you can enclose? So picture this, if you will. Here's my rectangle. Rectangles have a width and a length. If I have 100 yards of fencing, what is that going to give me? The area or the perimeter of my field? Fencing. Perimeter, right? So what's the perimeter formula? 2 L's plus 2 W's. I can divide everything by 2. That makes it a little easier. So L plus W equals 50. We can't work with 2 variables. So what would the L be? Or let's do the W. What's W actually equal? 50 minus L. Okay. So the area equals length times width, but we don't want to use the W. We're replacing it with this guy over here. That's a quadratic. You should be able to figure out the max. I can tell it's a max because it's a negative. You could rewrite this if you wanted to. Okay. So, find the vertex. The x part of the vertex is opposite of b divided by 2 times a. You're finding the x, but it's technically finding the L. That's the length. That gives you the maximum area. If I wanted to know the maximum area, you're going to plug that in. So the area is negative 25 squared plus 50 times 25. $625 yards squared. The dimensions that you get there, though, is 25 and 25. The length is 25, and the width is also 25. Okay. So that vertex is going to give you the x, which is your dimension for the length, and the y, which is your area. Okay? Last slide. Here we go. So this is the acceleration due to gravity formula. You don't actually have to know the formula. They're going to give you things. But this is always the initial height. And this is the initial velocity. And then the negative 16 is the gravity force in feet. Okay? What's the maximum height of the projectile? They're wanting max height again. So you need to figure out what x gives you a maximum. So you're going to be doing the opposite of b divided by 2a a couple times. So in 2 seconds, I'd be at my maximum height. And to find that maximum height, you're going to plug in the 2. So in 2 seconds, I will be at 464 feet. Okay? So picture this. I'm starting at 400 feet when I threw this off. What is this? We're shooting something. It's going to go up and down. They want to know now, when does it hit the ground? So what is that in the graph? The X-Intercepts, yes? So we have to solve. I'm changing these to x's because I do better with x's. All right. You can take 16 out of all of those. It's going to give you something that can't be factored. So if I can't factor it, I need to solve it. What am I going to use? This is when you have to use quadratic formula. Okay? So x equals opposite of b plus or minus squared minus 4 times a times c all over 2a. The 16 does not matter. That was just a scale factor. It doesn't change the x-intercept. It's a vertical thing, right? So using our handy-dandy calculators, this ends up being 400, or 4 plus or minus the square root of 116 divided by 2. Okay, there's our two answers, 7.4 and negative 3.4. What is negative 3.4? What do we call that? When it's an answer to the equation, but it's not an answer in real life. It's an extraneous solution. So we're going to cross that one off. Extraneous means it doesn't really work. It's mathematically it works, but it doesn't work in the real scheme of things. Okay? That's before. You have a negative time that's before you actually shoot it. Does that make sense? Everyone understand? Feel comfortable with quadratics? We've done it before. All right.